This question comes from Marcus, who asks, if the Earth's radius doubled overnight while keeping the same density and composition, what would actually change? The first thing to work out is what doubling the radius actually does to the planet's mass. Mass depends on volume, and volume scales with the cube of the radius. Double the radius, and you get 2 cubed 8 times as much planet. A body 8 times as massive but only twice as wide produces a surface gravity exactly twice as strong. So on day 1 of the new Earth, everything weighs double. You weigh double. Your car weighs double. The atmosphere weighs double. This is the number that drives almost everything else that follows. The most immediate effects would be structural. Most large trees, including California redwoods, would fall within hours. The taller the tree, the more energy it requires to pump water from its roots to its crown, and at double gravity. The energy cost of doing that exceeds what photosynthesis can supply at any meaningful height. Large animals would fare similarly badly. Running in twice the gravity puts roughly the same mechanical stress on leg bones as running while carrying your own body weight on your back, which is a good way to break a leg. Most animals above roughly dog size would struggle to move at speed without fracturing something. Humans could still walk, though it would feel like hiking uphill indefinitely, and anyone who needed to climb stairs would quickly understand why astronauts returning from long missions in low gravity need rehabilitation just to stand. Buildings are a different story. Counterintuitively, most modern skyscrapers would survive. Their structural limits aren't set by their own weight pressing down, they're set by lateral forces, wind loads, seismic shear, and the differential stresses of the ground moving. The additional vertical load from doubled gravity would be serious, but not, for most steel-framed buildings, immediately fatal. Bridges would be in more trouble, particularly long-span suspension bridges whose cables were engineered to precise tension tolerances. Then there's the rotation problem, and this is the one most people don't see coming. Angular momentum is conserved. Think of a figure skater pulling her arms in. She spins faster because she's brought her mass closer to the axis. The reverse is also true. Push mass outward and you spin slower. When Earth's radius doubles and its mass increases 8-fold, its rotational moment of inertia, the resistance to spinning, increases by a factor of 32. Since no external torque acts on it overnight, the planet's angular momentum stays the same, which means its rotation rate drops by a factor of 32. A day that currently lasts 24 hours would now last about 30% 2 days. This is where things stop being merely inconvenient and become catastrophic for the climate. A 32-day rotation creates temperature imbalances that the current atmosphere simply isn't built to handle. One side of the planet bakes for over 2 weeks of continuous sunlight, while the other freezes in 2 weeks of total darkness. The resulting pressure gradients between the scorched and frozen hemispheres would drive wind systems of a violence that dwarfs any storm in recorded history. The jet stream as we know it depends on the Coriolis effect, which itself depends on how fast the planet is spinning at a 32-day rotation. The Coriolis force is dramatically weaker, and weather patterns would reorganize into something unrecognizable. Ocean circulation, which is also partly driven by the Coriolis effect, would restructure as well, disrupting the currents that currently moderate temperatures in places like Western Europe. The atmosphere itself would be heavier. Double the gravity pressing down on the same amount of air means double the surface air pressure, roughly equivalent to diving about 10 meters underwater. This is still technically breathable. Commercial divers regularly work at such pressures, but breathing would feel labored, and the extra oxygen concentration at that pressure would raise the risk of oxygen toxicity over time. The moon would still be safe. Even with 8 times Earth's mass, the increased gravity wouldn't bring the moon inside its Roche limit, the minimum distance at which tidal forces overwhelm the gravitational cohesion of a body and tear it apart. The moon would instead settle into a new, tighter orbit, and tides on the new Earth, already wilder because of the stronger gravitational pull, would become more extreme still. In the end, most large life would not survive the first few years, not because of any single catastrophic event, but because almost every system that sustains complex life, the climate, the food chain, the ocean circulation, the daily cycle that billions of years of evolution have tuned organisms to, would have been rearranged simultaneously, overnight, with no warning and no time to adapt. The bacteria would be fine, though. They always are.